Hello, and welcome to the Computing Conversations column. This column is from the November 2013 issue of IEEE Computer and is titled Ian Horrocks, Standardizing OWL. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I am the editor of the column, and I'm Charles Severance from the University of Michigan. Early research into artificial intelligence essentially boiled down to capturing knowledge and making it available in a format that would allow software to behave more intelligently. For quite a long time, the syntax and the format used to record or enter this knowledge into files was tied to the very programs that would read and use it. Research groups would typically develop tools and define a format to feed knowledge into them. The hope was to build reusable reasoning tools that could function across many domains of knowledge by simply loading different knowledge sets into those systems. In the late 1990s and early 2000s, AI researchers realized that to maximize the usefulness of their work in an increasingly networked environment, they needed to standardize their ontology and knowledge representation languages and move the focus away from yet another syntax to represent knowledge to software that could evolve and use the knowledge and exchange it between different applications. I recently interviewed Oxford University's Ian Horrocks about the various ontology efforts and how in the late 1990s they were brought together, standardized, and normalized to produce the Web Ontology Language, or OWL.
My background had been working in medical informatics and developing what we would now call ontology languages and reasoning systems, although actually, to be honest, in the medical informatics area we weren't necessarily calling them ontologies back then. We do now.
Initially, those working in the AI field came from a very narrow area that was simply trying to capture and codify knowledge.
And I went to a meeting of a European network, met people like Frank van Harmelen, Dieter Fensel, who were also interested in this, got interested in the beginnings of this area, and I managed to convince them that this description logics area, which I'd been working in, which was a sort of logic whose rationale is to formalize what we now call ontology languages, that would be a good starting point. It had more expressive power and a very clear formal semantics, was just first-order logic, basically, just a fragment of first-order logic.
The first step towards developing a standard ontology language was a series of small meetings in which people simply shared their best ideas and learned about other approaches to knowledge representation. The small group developed a description logic-based syntax and language that they called OWL, or Ontology Interchange Language, and published their approach. As these small collaborative efforts were more broadly shared and published, more researchers became interested in the shared objective of growing the overall field through the use of standard ways to represent knowledge.
We met people in the US like Jim Hendler and the DAML program, people working on the DAML program. We all decided that, hey, we're more or less trying to do the same thing. Why don't we pool our resources, which we did. Came up with DAML plus OWL, wasn't really much different from the OWL thing, and then the idea was to go for, to try to develop this into a standard so more people would really be able to use it. And this was where OWL originally came in.
With the EU and US researchers finding that their approaches and goals were well aligned, they set about working with the W3C, World Wide Web Consortium, to produce a formal standard based on the DAML plus OWL approach. They initially expected that with DAML plus OWL well developed, it would be a rather simple effort to wrap up the standardization in a short amount of time. But as the group grew, more and more people learned about the work and became interested in the resulting specification and wanted to participate.
So then, of course, a whole new bunch of people joined the party, which were the sort of web people. And of course, they had a whole load of concerns of their own, things that were important to them, which were things like integration, compatibility with RDF, and generally with web infrastructure and existing standards.
The Web Ontology Working Group within the W3C formed in November 2001, just 2 years after the Ontology Sharing Day back in 1999. But in that brief period, many new people had come to the table, and these different stakeholders had needs to be addressed in the resulting specification.
So actually the process then of changing DAML plus OWL, evolving DAML plus OWL into OWL, took longer than we thought. It involved bigger change than we thought, and I think it took a couple of years in the end, and much more than that off my life, 10 years off my life, I think. But I mean, it was pretty interesting, and I learned a lot there as well, and the language evolved, not a great deal, but it was mainly the syntax and the relationship with RDF that changed. The underlying logic didn't change very much, and of course the semantics didn't change because that just flows from the logic.
Even though the Web Ont working group needed to address needs of myriad stakeholders, by December 2003 the standard was complete and published.
It's not that OWL was the perfect language, it's not that 15 mil is the right size for a pipe. It's just at some point you have to say, okay, I would have gone for 18 mil, you would have gone for 13 mil, we'll compromise here, we'll fix on 15 mil, we'll get on with it, and then we'll see what we can build with that. And this is what happened with OWL. There was huge arguments. In the end, we managed to reach a compromise that everybody could sign up to. Some with more grumbling than others, but everybody signed up to it. And then, people started building stuff.
With a standard language to represent knowledge, the field started to come together and produce tools and data that could be shared across research projects and commercial efforts.
We had a standard KR language that was kind of supported by lots of different groups building infrastructure, and suddenly applications people started to feel more comfortable about using that. It had always been an issue, if you were using the system from the University of X and then that research group just suddenly got bored with that and went off and did something else, so you were left with no support, whatever. Now with OWL, you could use a standard language, there were tons of people supporting it, ever-growing sort of array of infrastructure to support, building, deploying, maintaining ontologies.
As the field went from building one-off toolsets tied to specialized knowledge representation formats to an increasingly solid and reusable infrastructure, a wide range of researchers in computer science and other scientific fields could focus on solving the more interesting problems. Today, OWL and RDF are integrated into so many toolsets that users barely notice them.
And now the thing that amazes me today, with both OWL and RDF actually, is that you just bump into people all the time who are just building applications using OWL and RDF tools and infrastructure that you never even knew about before, because that stuff just works now. They just download it off the web, they build it into applications, they're pretty happy. It may not be, if you look at what they did, you may say, well, if I were doing that, I'm not even sure I would have really used RDF and OWL. But they downloaded the tools, worked really nicely, they were super happy with it, and the toilet flushed in the end. Job done.
The efforts to standardize RDF and OWL have produced unintended benefits for our field. Those who use these technologies daily typically have no idea about the innovators who took the time to reach across research projects to come up with a unified and general-purpose approach that is widely usable.
And I think one of the things as a community we haven't been very good about is embracing that as a great success and saying, we've done a really good job here, we've built stuff that people are using and it works. It really kind of works off the shelf these days. The tools and stuff are pretty robust, and we should be proud of that. It's an achievement of the community.
This column is from the November 2013 issue of IEEE Computer and is titled Ian Horrocks, Standardizing OWL. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I am the editor of the column, and I'm Charles Severance from the University of Michigan.